this is my current lab, and I've got different networks. I've got one for the lab. I've got one for IoT devices. I've got one for all my computers, my personal work, but all the computers that are mine. And then another one for, I call rest of the world, which is exactly that. Anybody else that connects to my lab or my house or anything that goes to the rest of the world. And I've got them compartmentalized in a way that some of them don't have internet access, some of them don't. Some of them do have internet access, but they're very limited in the geo that they can reach out, mostly US, Canada, Western Europe. And I think that's pretty much it. And then I've got also limitations in terms of who can talk to whom. So I've got my own network that has outbound access to all networks through Secure Lobby, of course. Then I've got IoT devices that can receive communications from my network and the rest of the world. Then rest of the world can talk to IoT devices. Of course, it can only receive communications from me. And then lab, which is only accessible by me. But on top of that, the demo lab policy, the inbound connections only from my zone and outbound to nobody. But also, if I go to the policy demo lab, then you see that it's in a scenario where it has no internet and only inbound secure lobby routing, which means that any device that is inside this microsegment will, on layer 2, allow communication from secure lobby, but not establish anything outbound to either secure lobby, to the local LAN, or to the internet. So pretty much nothing other than receiving and accepting sessions that are coming from a vetted entity in secure lobby. That's via layer 2 access control. Then if we go to layer 3 access control, and I'll see that the policy demo lab is in the zone demo lab. So then I go to the zone demo lab, and I'll see this is where we were before, 10.10.40/24, and it can only receive connections from Matias. That's it. So on layer 2, the assets cannot communicate out to anything. They can only communicate, receive and accept sessions that are coming from somebody else that has been allowed through the overlay and into that zone. And then on layer 3, they have one more limitation that is only from the devices that are coming from the Matias zone. And if I go to the Matias zone, you'll see that the only members right now are my computer right here, right there, which is the computer that I'm recording this from. And if I go to my Byos management, I'm connected to the edge Matias, which is this one right here. And my secure lobby IP address is 10.10.53, which matches this. So all is good to go. So on layer 2, I am allowed to talk to devices on the demo lab session. On layer 2, I'm allowed to talk to the secure lobby outbound. I didn't show that part. If I go to the Matias policy, I have scenario D, which means I have full internet access and full overlay access through secure lobby, meaning that this session right now, my connection to Zoom and the recording that I'm making right now, and that my connectivity to the internet altogether is routing through Byos, using Byos as an exit node. So to my computer, everything routes through that. And my computer cannot distinguish between overlay traffic and internet traffic. It's all going through the one gateway, which is Byos. And that is all the intelligence my laptop has about, what's going on in the sessions. So I can talk to secure lobby outbound, and I have on layer 2, and then on layer 3, I have access to the demo lab. So let's see what we have available on layer 4. If I go to list out the assets, I'll see that let's filter it out. On the demo lab, I've got multiple machines. I've got a desktop, which is a VMware, a VM. I've got the actual ESX hypervisor, which we're going to skip in a second. Then I've got other VMs that are right there. I've got an Office printer, which is a Brother Industries printer, and then 2 more VMs. So essentially, I've got all these are assets within that microsegment. Each one of these is an asset, and they can be managed independently. They can be managed depending on what you need specifically from those. If I go to the multi-one and I open that, you'll see that Byos automatically, first of all, Byos automatically discovered all these assets, but also Byos has discovered this port and service on this machine. It discovered an SSH service on port 22. Now, you see the little I is in purple. It says enable and secure lobby. That's because I've enabled it in the past. But if I disable it just by clicking on it and going to this toggle, enable and secure lobby, disable. What I'm doing right now, what the platform is doing is sending the command that I set, disable port 22 on that asset, is sending the command to the proper gateway, and then the gateway is shutting it down at the layer 2, layer 3, layer 4 locally on that microsegment. I don't know where this asset is physically located, nor I care. That's the beauty of Byos. Physical limitations disappear. When I look at this map right here, there are no offices, there are no walls, there are no public IP addresses, there are no DMZs, there are no VLANs, there are no segments, there are none of that. You only have zone access via the overlay. And that's part of the beauty of managing this. Even devices in the same zone can be in different continents at the same time. It doesn't matter. So when I go back to assets and I go back to that multi-one, the service is still there. Now the I is grayed out. Now, because I have access on layer 2 to talk to the overlay, and Demo Lab has access on layer 2 to receive sessions from the overlay, and I've been allowed on layer 3 to talk to this zone, as you can see again on the map. Matias has outbound access to Demo Lab at the bottom. Then all that I need now to complete the cycle and close the loop and be able to access that device is permission on layer 4, which again, you stack up permissions. It's not either or. All of them have to be there for you to be able to establish that session. And I'm going to show why that's important in a sec. So if I go back to assets and I go to that multi-one, again, SSH is disabled. So if I open up a terminal and I do SSH BIOS at the IP address that the edge was given to by BIOS, the platform 10.10.41, of course, it's not going to work. And you see, you get a connection refused. Like if the cable were disconnected, like if the port was closed, because that's really what it is. Effectively, you're not getting an access denied. You're getting a resource not found. You're getting a request timeout. You're getting a connection refused because the session cannot even be established. What happened at the bottom is that you sent out a SYN packet and you got an RST, you got some of those. You didn't get an ACK for sure, and you didn't also get nothing. You got a nothing. You get a resource is not there. I don't know if it's an RST, maybe. Jim, maybe you can help me out with that, but it is not a timing out of things, waiting for something to happen. It is a nope, not going to happen. But the moment I turn it on via secure lobby, and I just clicked on the thing, it's going to push the request to the edge. And as soon as that happens, the session is established. And I now am inside this VM through the ether, through the limbo that it is the BIOS platform, whereas no, there are no routes, there are no physical. I, as a user, don't know exactly how I got there. All I know is that I got there. But at the same time, the VM itself doesn't have access to anything, doesn't have access to the internet, doesn't have access to the overlay. I can even try pinging my IP address, 10.10.53, and it's not going to work because, as we saw before, the demo lab session, the demo lab policy only allows inbound to secure lobby. Now, if I change it to, for instance, internet plus inbound secure lobby, then that should mean that the traffic to another BIOS edge should not happen, but traffic to the internet should happen. Let's try that out. I'm going to click save. And again, it's going to push the policy to those gateways, push, apply, et cetera, And now if I do this, the internal IP address of BIOS is not going to work, but the IP address of the internet is going to work. And that's how you can start breaking apart the type of traffic that you want done. I'm going to change it to something else. I'm going to go to Demo Lab, and I'm going to actually invert it. I want to have the opposite effect. I want it to have inbound and outbound, sorry, not this one. Full secure lobby routing, meaning I want to be able to also establish a session out to the lobby, but I don't want internet access. I'm going to push that. And then now that I'm there, the results should be the opposite. If I ping the internet access, don't have access. But if I try to ping 10.10.53, I have access. And now I have layer 3 access to that zone. Now, there's nothing there waiting for my edge because I haven't established anything on this side of the equation. But that's the beauty of how you can actually switch things up and allow very granular access to different things. I'm going to reverse that to only inbound. And as soon as I do that, the traffic is gone. The traffic to the other secure lobby IP addresses is gone. The same works with any other protocol. I go back to assets, and on Demo Lab, I got a Windows machine right here that is BIOS detected all these ports, 80, 135, 445, those very nasty ports that we all know about Microsoft. We don't want to enable those. So I want to be able to remotely access that Windows machine via 3389 via RDP, but I don't want to have those other nasty ports open. I would say a very high percentage of exploits towards Windows machines are coming from those services. I don't want them, but I still want to be able to access those machines, those machines via RDP. So I put the assets behind microsegment, so they are invisible on the local network. And then I only allow a very granular access via layer 2, 3, and 4 with BIOS to be able to use RDP. If I shut it down, let me show you. So I shut it down and I open my RDP session and I add the thing 10.10.41. Not going to work. But the moment I open it, and now I can work. Administrator. And I log in. And you're going to see the same thing if I open up. I'm going to make the window smaller so it's easier to manage. If I open up a command prompt and I ping, whoops, then you're not going to get anything. Think of all the functionalities that you have for which you don't need internet access. WSUS, file servers, data servers, streaming services, anything that you use normally within your network. Those devices, especially the servers, don't really need to be exposed to the internet. So why would they? And this you can accomplish very easily with our solution. And if you want to change that dynamically for either 5 minutes or 5 days, or for whatever reason, then you can click 2 buttons, three buttons, change it, do what you need to do, and then bring it back to a safe position without having to go on site, without having to pick up the phone and call someone to start switching cables or opening up local firewall ACLs, et cetera, et cetera. You do it from here, do what you got to do, and then shut it down, and then you're done. So the attack surface goes down significantly to a tiny thread of both time and space for the attack surface itself. And then it's a clean back and forth.
I think what's important to note here, Matias, is there's three subjects or three topics here that are being addressed simultaneously. First is that these conversations are contextual only. So we're not allowing traffic to freely flow in all directions at all times, thus shrinking those threat vectors. So that's number one. Number two is because these conversations are all contextual and we're controlling the flow of traffic at multiple layers, we're providing the ability to work within certain frameworks like IEC 62443. And then last but not least is that delicate balance between security and functionality. And as you can clearly see, you're so quickly moving around and everything is very snappy. And there is no real delay, right? There's no lag, there's no drag. So I think we're kind of, well, not even kind of, we're actually addressing three very important issues from a security perspective. That's ease of use, that's compliance, and that's the flow of controlling the flow of traffic to shrink that threat vector.
Yeah. And we don't need to, users or customers don't need to choose between operability and security. You can have both. You don't have to choose between one of them. I got to open up stuff so I can work on them, but that means that it's open for everyone. That statement goes out the window with Byos. Yep. Best example I can show on that is if I go straight to the ESX hypervisor. So this is an actual ESX hypervisor that is hosting the other VMs that you see on screen. It detected a bunch of ports, 44380, then a couple of proprietary ones for VMware use. And then you've got port 22. Now, port 22 is not open by default on a hypervisor. That's good practice to have it disabled. I opened that port up on purpose for this demo. But that's the point. It's so hard to contain those services that the manufacturer shuts down the service locally on the actual machine, and you then need to go in there and tweak some stuff on configs and then open it up. That's how critical it is to not expose these ports, because they can be very dangerous, and that's how far they go to get to have a little bit more certainty that you're not going to be exposed. So I went ahead and I read through the help and internet, and I opened up port 22 just so it can be discoverable by Byos on this demo. But I'm not going to use port 22 for now. I'm going to use port 443 that has been allowed by Byos on the same IP address for the edge, 10.10.41. So if I go 10.10.41, I'm going to log into that ESX hypervisor. On the typical, I don't have the vSphere client. I use web, but it would have been the same for the vSphere. So I'm going to log in to the dashboard, and as you can see, I'm going to zoom in. It's telling me that SSH is enabled and that I should disable it. It doesn't like it. Of course it doesn't like it. It's a very dangerous port on a very dangerous machine that is wide open to the network, or so the ESX hypervisor thinks, because we have not allowed it on the BIOS layer. And then again, remember, you've got the asset, you've got the BIOS layer, and you've got, let's say you've got a firewall. You can still keep your firewalls, of course. Let's say that you have not blocked anything on the firewall. You've not explicitly blocked it, but even if you blocked it, it doesn't affect the local traffic within that segment. So port 22, it's going to work. So if you don't block it on the segment, and if you don't block it on the asset, then the service is essentially available. So what you do with Byos is, because you have that layer in between, it doesn't matter what you've done on the firewall side. It doesn't matter that the firewall ACL doesn't apply to local traffic across that segment, and it doesn't matter that you have the port open on the asset, because you've got one more layer in between, which is Byos, and it is shut down, explicitly shut down on Byos. So if I want to do, even if I am on the console right here, I'm going to exit this. If I do SSH 10.10.41, sorry, it is going to work because it is mapped to this other machine right here. the multi one. I'm going to shut it down just to show you graphically. So it is now shut down. So even though I'm connected to the ESX on the 443 right here, and it says that SSH is enabled, it is not enabled at the BIOS layer. So if I do this, then it's not going to work. But the moment I turn it on the BIOS side, then it's going to ask me for credentials. Don't remember the password. Do I? Don't remember the password for this. No. But it doesn't matter. It's beyond the point. I get access to the thing via SSH. And nothing changed right here. This is now technically I should care about this alert because I've enabled it on the BIOS side, which means that it is accessible. But remember that layer 4 only comes after layers 3 and 2. So it is only going to be accessible to the entities that have been allowed outbound access to the overlay on layer 2, and then to the entities that have been allowed access to the demo lab on layer 3. So you're still reducing the attack surface significantly. But even to those entities, SSH is now accessible. The moment you shut it down, this thing is still fine, still accessible. It's still working normally. I'm still going to get the warning, of course. But this is not going to work. SSH is gone, done, closed, even though the warning is still there. And that's the beauty of it. You go from an exposure, an asset exposure to the entire network, and then you close it to only expose it to microsegments, only to a tiny subset of microsegment, and then only to a certain amount of people or other assets that have access to that machine. And then you close it a little bit more by just the one machine. And then you close it a little bit more to just the one service. And then you close it a little bit more to just only for the 2 hours that my support ticket requires access to this thing. And then I shut it back down. So the attack surface goes from here to a very tiny thread. Never going to go back to 0, but it's going to go to such a small percentage that your risk factors are going to go down significantly. And if you only proactively turn it on, the exposure to something, when you actually need it for, again, like 2 hours and then shut it down, you're getting so close to 0 on the actual exposure that it's a pretty significant enhancement from status quo. And that's what we are here to offer. That's the value that Byos brings to the table. It's about reducing the attack surface so much that it is practically impossible to effectively launch an attack against your network. And if they can launch an attack against your network, the chances of it being successful are so low. The chances of them being able to exfiltrate information are low. The chance of them being able to laterally move, pivot, or exploit other machines is so low. The chances of them establishing reverse shells, reverse communications for persistence are so low that if you look at the kill chain completely and you attach every step of the kill chain, you apply a delta or a percentage of likelihood with and without BIOS to each one of them, then the total net is going to be so low that is going to make a big impact on your entire risk mitigation strategy. And that's what we do.